Okay, ready calculator ha? Okay, so mamaya magko-call tayo ng people para magsagot. Okay, so let's start. Question number 1. Typical seawater contains 2.7 grams of salt or sodium chloride per 100 ml volume. What is the molarity of NaCl in the ocean? Okay, so to answer this, so since ang question ay molarity, all we need to do is to find kung ano yung equation for molarity. So the equation for molarity is what? Mole per volume in liters. Okay? So ginaganyan ko po talaga. Pag may nakita kayong V sub L, V subscript L, ibig sabihin yon volume in liters. Okay? So para ma-remind tayo na the unit should be in liters. Okay. So yan. Then, what's the problem? We are given with the mass of the salt and not the moles, no? So, pwede pa rin natin yan gamitan ng another equation, no? Remember that mole is mass over the molar mass of your substance. Hence, we can rewrite the equation as the mass of salt divided by the molar mass of the salt times the volume of the solution in liters. Okay? Then what's next? Plug in tayo ng info. So let's have 2.7 grams of salt in the numerator. The molar mass of NaCl, tingin kayo sa inyong periodic table. So, dun sa periodic table natin dyan sa chat box ninyo, hopefully tinitignan nyo siya, we will use all the units, no? So, kung ano yung units na nandyan, kung ano yung numbers, lahat yan gagamitin, okay? So, usually, ang decimal places dito ay 3. Okay, so lahat yon gagamitin natin, okay? Para hindi magtampo yung ibang numbers, okay? So for Na, according to the periodic table, that's 22.900 grams per mole. 990 pala. 22,990 for Na. Cl naman is 35.453. Okay? So again, we are going to use all the digits sa inyong periodic table. Okay? So ito yung printed version ko. Lahat ng numbers dyan gagamitin natin. Okay? So let's add the 2 to get the molar mass of the substance. So that's 22.990 for sodium, 35.453 for chloride. So the molar mass of sodium chloride is 58, pangit yung 8 ko, 58.443 grams per mole. Siguro yung iba tapos na mag-solve, no? And then lastly, volume of the solution in liters, no? So we have here 100 ml of solution. However, it should be expressed in liters. Now, what's the equivalence between liters and ml? Now, 1 liter is equal to 1,000 ml. Okay, so basically to convert ml to liters, you have to divide it by 1,000. No? So we can express 100 ml as 0.1 liters. Okay, so yan yung volume of solution in liter. And then let's solve, no? Kailangan ko pa po ba dito ng significant figures? Hindi na, no? So usually, I will ask you to express the answer in 2 or 3 decimal places na lang. So hindi na natin i-consider yung sig fig ha, sa lecture na yon. Hopefully na-discuss na sa inyo sa lecture. Pero sa ngayon, no, since ang daming numbers, di mo alam kung anong sig fig susundin nyo, gawin na lang natin for now sa laboratory part, no. So let's use 2 or decimal places, no. So sa ngayon, mag-ano tayo, 3 decimal places. So the final answer is 0.462 mole per liter NaCl solution, and that's our answer. And so, do you have any questions with regards to the calculation or wala naman na? Okay. So, without any questions, pwede tayo mag-proceed with the next one. I'll skip number 2. I will leave this sa inyo. Okay? So, kayo na bahala sa 2. No? Ako. Okay. So, ganun gagawin natin ha. May items na i-skip ako. May items na ako yung magsasagot. No? Kayo bahala dun sa mga i-skip ko para, para mag-practice pa rin kayo. Okay? So, yan. So, we're done with number 1. The answer is 0.462. Again, remember the equation for molarity, mole per liter, or in terms of grams, that's gram per molar mass times volume in liters. Again, the volume should be in liters. No? And for the molar mass, let's use all the digits of the periodic table. I already uploaded you a copy of the periodic table I am using. No? So, ganun. Para iisa yung sagot natin. Okay? So, next one. Let's have number 3. Find the molarity and the molality. Oh, by the way, we did not discuss molality. No? Ano ba yung molality? No? This is a concentration unit, no? Na similar with molarity, pero hindi na natin discuss. Bakit? Kasi for anachem, ang ginagamit natin ay molarity. No? Saan ba ginagamit ang molality? We use molality in physical chemistry. Yun yung chemistry ng physics. No? Okay, so may chemistry na physics style. Doon namin ginagamit yung molality. Okay. So to give you an idea how different yung dalawa, ano yung similarity nila, ano yung difference nila, ganito. Yung molarity, capital letter M yan. Okay? So that's mole per volume in liters of the solution. Okay? Pag molality naman, ito, molality. That's small letter M. Molality. Kakabulol na. So the formula is similar. That's the mole of your substance. However, yung denominator, instead of volume, we use the kilograms of solvent. Okay? We use kilograms of the solvent, not the solution. Okay? So, yan. So, yan. Yan yung difference nila. So, medyo similar sila. Mole yung nasa numerator. However, yung denominator, dun lang sila nagkakatalo. The volume of solution for molarity and kilograms of solvent for molality. Okay. Bakit ito yung gamit sa physical chemistry? Because we are dealing with different temperatures, di ba? And we know that at different temperature, the volume changes, no? However, yung molality, hindi yan nagbabago despite of anong temperature man yan. Okay? Kasi mass yan eh. Mass din to. So, constant yan. Okay? So, the molality is constant. However, the molarity changes due to the temperature effect no sa density ng solutions no. So yun. So we'll skip the part of molality no. Okay. So nilagay ko pa rin diyan para maalala ko, ikukwento ko siya no. Okay. So skip natin yung molality. Molarity lang muna tayo. Okay. So question, find the molarity of 37% weight of HCl. The density of a substance is the mass per unit volume. The density of the reagent is 1.19 grams per ml. Okay. So, paano to? Binigay lang sa atin, percent by weight, and hinahanap ay molarity. Okay? So, that means we are going to convert one unit of concentration, one concentration unit to another. From one concentration unit to another. Okay? So, is that possible? Yes, no. Okay, ano lang kailangan natin maalala? From this concentration unit, kailangan makuha natin yung mass ng solute, mass ng solvent, mass ng solution, etc. No? Okay? So, ganito ang gagawin natin. Pag may nakita kayong percent weight, no, always assume that you have 100 grams of solution. Okay? So, ganun ha. Every time you see percent weight, you always assume 100 grams solution. Okay? Bakit 100 grams? Kasi pag 100 grams times 37%, ibig sabihin nun 37 grams yung inyong HCl. And then, yung remaining, that will be your solvent. Ano yung solvent nyo? Water. Because in chemistry, in analytical chemistry, the solvent is usually water if not stated. Okay? So, ganun yung gagawin nyo ha. Sir, pwede po bang 1,000 grams? Okay lang. However, mas madali na yung 100. Bakit? Kasi ang gagawin nyo na lang, tanggalin nyo yung percent weight, palitan nyo siya ng grams. Okay? So again, ano yung tip ko sa inyo? Whenever you see percent weight, ano gagawin? You assume that the mass of the solution is 100 grams. Okay? So, ganun lang. 100 grams parate. And then, i-divide mo yung solution mo into solute and the solvent. Okay? So, ganun. Although solute lang yung focus natin, ha? Kunin pa rin natin yung mass ng solvent. So, kung 37 grams yung HCl, how many grams yung water as your solvent? So, you have 63 grams of solvent na. So, ganun po. Okay? So, yun yung first technique na kailangan nyo alalahanin. Again, every time you see percent weight, you assume that the mass of the solution is 100 grams, no? So that kung ano yung percent weight ng substance na yon, yun na rin yung corresponding mass niya. Okay? For this problem, 37% yung HCl. So since we assume that the solution is 100 grams, that means HCl is 37 grams, no, sa solution natin. Okay? So, let's set this aside. Sulat ko lang na maayos sa gilid. So, if we have 100 grams solution, that will be 37 grams HCl and 63 grams H2O. Okay? So, what else? Ano pa yung mga kailangan natin gawin dito sa question na to? Okay? So, recall that since we are solving for molarity, ano yung kailangan doon sa denominator ng molarity? Volume of the solution in liters. Do we have the volume of the solution in liters? Wala tayong volume ng solution. Ano meron tayo? Mass ng solution. Because dito tayo nanggaling sa percent weight. No? And we assume that the solution is 100 grams. Ito yung question. Is there a way to convert the mass of solution into the volume of the solution? May way ba from mass gagawin kong volume? Mass ng solution, volume ng solution. No? Anyone, you can raise your hand and use your microphone. Okay? So, meron bang paraan? Tignan nyo yung problem. Meron dyan. Basahin nyo lang maigi. Para ma-convert ko yung mass ng solution to the volume of the solution. Anyone na may clue? You can raise your hands po para ma-recognize natin. Okay? Si Zylene. Okay, density. Okay? So, yun din naman sagot ni Jamie, di ba? Okay. So, density. So, the density ang gagamitin. Okay? So, ano ba yung purpose ng density? To convert mass to volume. Okay? So, ganun lang. Okay? Sa mga new students ko, no, ganito yung ginagawa namin last semester. No? Yung students ko yan, si Zylene, pati si Jamie last sem. So, pag nagsasagot ako, paparaise ako ng hand. So, feel free lang to raise your hands, no? O kaya type nyo na lang yung sagot. Okay? So, ganun. Ganun kami mag-recitation eh. Walang pilitan, no? Kung sino lang gusto mag-recite, yun na yun. Okay? So, yan. So, we are going to use the density of the reagent. When you say reagent, yung solution yun. Okay? So, we're going to use that to convert the mass into volume of the solution. Okay? So, ano gagawin natin? Density formula, mass over volume. We are looking for the volume. So, we have to rewrite the equation as, excuse me, volume is equals to mass divided by density. So, ganun gagawin natin, ha? So, we will use density formula to solve for the volume of the solution. Okay? So, volume, dito ko na lang sulat na maayos sa gilid. So, volume of the solution equals mass solution divided by density ng solution. So, we have volume solution. Numerator would be 100 grams. Density ng solution would be 1.19 grams per ml. Okay, so for sure may decimal to. Divide lang natin. 100 divided by 1.19, 84.0336 something something. So, pag ganyan po, ilang decimal places gagamitin nyo, sir? Pwede na yung pwede na yung tatlo. Okay, tatlong decimal places. So, that will be, That will be 84.034. Okay, 3364 eh. Okay, so, 3364. 336. So, round off mo siya, 34 na. Okay, so this will be the volume of the solution in liters. However, liters pala yung kailangan. Okay, so paano ko yan i-convert into liters? Just divide this by 1,000 na. Okay, so convert mo lang yan into liters later on. Later on na. Okay, so basta ganun. So, do we have the info necessary para sa calculation ng molarity? Yes, no. We have the mass of the solute, the volume of the solution, then we're good to go na. Okay? So, ganun lang. Hanapin mo yung mass ng solute, yung volume ng solution, using the two given info lang. Okay? So, ayan. Let's solve for the molarity na. So, molarity, mole per volume in liters. Ayusin ko sulat ko. Wala kasing lines eh. This is mole per volume in liters. And we can expand this as mass ng solute. In this case, HCl. Mass HCl divided by the molar mass of HCl times the volume of the solution in liters. Okay. Then, ano gagawin natin? Plug in. Okay, plug in. Mass ng HCl, this would be 37 grams. Okay. Ayusin ko lang yung 7 ko. 37 grams. Yung molar mass ng HCl, gagawin, periodic table, lahat ng digits gagamitin. Okay. So, for hydrogen, that's 1.008. For chlorine, that's 35,453. So the molar mass of HCl is 36.461 gram per mole. And the volume in the solution will be expressed in liters, no? So, kapag kinonvert pa kasi natin to, baka mag-round off pa ulit tayo, no? So, ang gagawin ko na lang, isusulat ko na lang yung ml. Kasi kapag too much round off, na yun, sobra-sobra na, susulat ko yung ml, dito ko na lang siya i-divide by 1,000 ml per liter. Okay? Para yung calculator na bahala, no? So again, ito, hindi ko siya kinonvert directly to liters kasi baka mag-round off ulit tayo, nawala na yung mga numbers, no? Masyado nang nawala yung info, mga details. So, gagawin ko na lang kung ano yung nakuha kong ml, lalagay ko doon. However, I will divide it by 1,000 ml per liter. Okay. So, the purpose is to convert ml to liters. Magka-cancel naman yung ml. Okay. Yan. And then yung liter, yun yung matitirang unit. Okay. Nawala. Nawala talaga. Okay. So, yan. Let's check if the units will cancel. Cancel yung grams, cancel yung ml. So, we're left with mole and liter. So, what's the final answer in 3 decimal places? 37, 36.461 divided by 1,000. Dinig na dinig yung calcu, no? Galit na galit. Okay. So, the answer is 12.076 mole per liter or molar. Pwede na yung capital letter M para masanay kayo. Okay. Mole per liter na lang. Okay, so that's the molarity of 37% HCl. Okay. Yun. Yun lang. Okay. So again, how are we able to solve this item? Paano natin ito nasagutan? First, we assumed certain mass for the solution. Pag percent by weight yan, always assume 100 grams ang solution mo. So that yung kung ano yung percent ng inyong solute, yun na yung kanyang mass in grams. Okay? So wala na kayong ibang gagawing conversion. Kung gusto niyo pahirapan sarili niyo, edi pwedeng ibang mass ng ibang mass ng solution. Kunwari 31.32 grams ng solution. Kayo bahala, choice niyo 'yan. Pero mas madali kung 100 grams, okay? So yan, makukuha mo yung mass ng solute. Then from the mass of the solution, you get the volume of the solution. Okay? This is the volume of the solution in ml using density formula. And then you will plug in all those information in the molarity equation. So you will end up with the final answer, 12.076 mole per liter. Okay, so yun lang. Okay, so sa ngayon, hindi natin skip tong number 4. I want you to answer this ngayon. Okay, so gusto ko may sasagot dito. Ang paano gagawin natin doon? Ang gagawin natin, sulat kayo sa papel, sulat nyo lang ang sagot nyo. So I will give you, let's say, 5 minutes to answer this problem. Then, may isang mag-upload ng picture ng sagot niya sa chat box natin. Okay, so paunahan kung sino yung gusto mag-recite. Okay? So, not graded naman, no? Pero it doesn't mean na hindi nyo nagagawin, ha? Gawin nyo pa rin, no? Kasi I will tell you, yung quiz 1 medyo tricky siya. Pag sinabi ko yung tricky, tricky talaga yun. Pag may medyo, ibig sabihin medyo tricky talaga, no? So, yun. Kasi ang daming pwede gawin sa calculations, no? Okay? So, practice tayo. Yun yung purpose ng meeting natin today. Okay? So, I'll give you 5 minutes to answer this. So, I'll return to you around 11:22, no? And then, magko-call tayo ng isang person. You raise your hand, then upload your answer dito sa chat box natin. So, makikita natin yung solution. Okay? Sige. So, I'll give you time. I'll be back in 5 minutes. Sir, di po kasama Molality. Yes po. Just in case lang. Teka lang. Ayan, low bat na. Okay. So, kunwari nagtataka kayo, sir, paano mag-solve ng molality? Okay. Kunwari, question lang sa isip niyo, paano ba mag-solve ng molality? Sige, turuan ko kaya. Paano mag-solve ng molality? Okay, we will still use the given info dito, ha? Dito ko na lang sulat yung molality. Number 3, molality. So, molality is small letter M. Okay? Tapos ang formula niya ay mole per kilograms ng solvent. Okay? So, ganun. So, yun yung molality. Ang molarity, capital letter M, ito yun, capital letter M siya, mole per volume in liters ng solution. Si molality, small letter M, mole per kilogram solvent. Okay? So, ganun gagawin natin dyan. Tapos, next is yung mole. Okay? Di ba, alam na natin paano kunin yung mole. Ito yun, 37, 36, kopyahin mo lang yan. Okay? Then, paano po yung kilogram per solvent? Okay? So, ito na yung mole, no? Mass over molar mass. Yun na yun. Question, paano po yung kilogram of solvent? Ano ba yung solvent natin? H2O. Asan yung mass ng H2O? Ito, 63 grams. So, gagawin mo, you convert that into kilograms, no? So, that's 63 grams divided by 1,000 gram per kilogram. Okay? So, by dividing it by 1,000, you will get kilogram na. Cancel, 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 cancel. You will be left with kilogram per kilogram and mole units, no? So, yan. So, again, for molality, mass ng solvent ang kailangan. Solvent, hindi solution. Okay? So, you will convert this mass of solvent to kilograms na. So, ganun gagawin. Pag molality. Solve natin. Medyo magkalapit lang yung answer dyan. No? So, pag sinabi kong magkalapit, hindi naman greater than 10 yung difference. Okay, so the answer is 16.108 mole per kilogram. Okay, so that's the molality. Okay, so mapansin nyo, medyo magkalapit yung value nila, no? Okay, so medyo magkalapit lang. Hindi siya greater than 10 yung difference. Okay. So yun. Pero again, in chemistry, we will use molarity, no? In anachem. Yung molality sa physical chem yan eh. Okay, so sa ganito na lang gawin natin since nakwentuhan na natin yung molality. Yung sa number 4, sagutan nyo molarity and molality. No? So, dalawa yung sagutan nyo. So, since na lang, 1 minute na lang, gagawin ko na lang, balik ako by 11:25. Okay? So, you present your two answers. Yung isa sasagot ng molarity, yung isa sasagot ng molality. Okay? So, I'll be back by 11:25. Okay, any volunteers for the molarity number 4? Yung pusa ako nag-volunteer. Okay, so let's have Jacel Villaflor. Okay, so Jacel Villaflor uh, will be posting sa ating chat box yung molarity calculation niya. Okay, how about molality? Sino gusto sa molality? Wala pa sa molality. Okay. Wait, Mingming. Baba. Okay, so for molality, sino pwede? Urong ka dun. Papapansin yung pusa ko sa inyo. Okay. Hello daw, sabi niya. Okay. Okay. So, tignan natin ang solution ni Jason. At lang, labas ko lang yung pusa. Ang kulit eh. Okay, so tignan ko muna ang solution. Wait lang ha. Okay, so tama ang sagot ni Jason. So, pakita natin sa class. Drag ko lang tong Teams. Okay, so ganito ang solution, and this is correct, no? Okay. So, ang una nyong gagawin is from the info, so you have 49% weight of HF, no? So that means if you have 100 grams of solution, 49 grams of which is HF, no? And the remaining 51 gram is water. Okay. Then ano susunod? Since we are solving for molarity, okay, so we need the volume of the solution. Okay. Derived from the density formula, we solve for the volume of the solution. That's mass divided by the density, or 100 divided by 1.16 grams per ml. So this is the volume of the solution in ml. Okay. You solve for the molar mass, and then this is the calculation for molarity. So molarity equals mole per volume in liters. Okay. Then we plug in the mass, 49 grams, the molar mass, which is 20 point something grams per mole, times the volume of the solution converted in liters. No? So that will be 86 point something divided by 1000 ml per liters. And then the final answer will be 28.6 something mole per liter. Okay? So, hindi ko makita eh. Labo mata ko. Nandun yung screen eh, sa kabila. Okay? So, that's our answer. Hopefully, you got the correct answer then for others. How about molality? Okay, so how about molality? Is any volunteers? Ito yung sagot dito sa molality, malayo ha. Malaking difference. So let's have Lian Micaela. Okay, so message mo na lang sa chat box natin yung answer. Okay, so ito na yung answer ni Lian. Okay, so still with the same info, okay? Ito yung ating ito yung ating calculation for the molality, small letter m. So that's mass divided by the molar mass times the kilograms of the solvent. So you convert 51 grams solvent by 1,000. So you will get this number. You divide them and then you will have molality equal to 48.025 mole per kilogram. Okay. So ano mapapansin nyo when kung kailan nagkakaroon ng excuse me, kung kailan nagkakaroon excuse me. Ba yan? Kung kailan nagkakaroon ng deviation yung molarity and molality. Okay? So, nagkakaroon ng malaking changes sa molarity and molality if the solute is concentrated. No? Pag tumataas yung concentration niya, mas lalong lumalaki yung difference nila. However, for dilute solutions, ibig sabihin nun, onting solute lang yung nilagay mo sa solution, medyo same sila. Okay? So, ganun lang. Excuse me. So, ganun ha. So, kapag malaki yung concentration, malaki yung change sa molarity and molality. Note nyo yun. Baka lumabas sa quiz eh. So, note nyo. Pag malaki yung concentration, molality and molarity, big difference sila. Pero kapag dilute yung solution, ibig sabihin, onting solute lang yun nasa solvent, ano lang yun? Same halos. Okay? So, ganun. So, let's have the next problem. Okay? So, this is the next problem. This is about preparing solutions naman. So, let's have this. Itong 5 sa inyo ko na ibibigay yan, ha? Ano lang yan? Parang similar yan sa question sa PowerPoint natin na yung barium chloride dihydrate. Okay? So, ganun din yung idea sa 5. However, tignan nyo yung unit, no? Let's small letter M, capital M. So, ibig sabihin nun, millimolar. Okay? Pag may nakita kayong ganito, mm, yan ay millimolar. So, ibig sabihin yan, that's 1,000, 1 over 1,000 ng molar. Okay. So, you can use Greek prefixes din dito kasi, no? Pwedeng millimolar, pwedeng micromolar, nanomolar, pwede yan, no? Pwede mo siya gamitan ng Greek prefixes. Okay. Kasi, to unit of measurement din to, di ba? Nasa SI unit to. So, pwede mo siya gamitan ng Greek prefix. Okay. So, etong mm na yan, small letter M, capital M, millimolar. Okay? Baka isipin nyo, molality. No, hindi. Millimolar yan. Okay, so I will leave this to you. No? By the way, mali pala yung ion ko. This is copper 2+. Okay, so anyway, SKL. So, gagawa tayo ng, itong 6, bibigay ko na lang din sa inyo to. Dilution lang yan. Number 7. Ito, number 7. Ang daming gagawin. So, basahin natin. A solution of ammonia in water is called ammonium hydroxide because of the equilibrium. Ammonia plus water equilibrates into ammonium hydroxide. Okay? So, yung equilibrium reaction sa future natin malalaman yan. Chapter 3 and 4. Okay? Kapag yung ammonia kasi nilagay mo sa tubig, naging ammonium ion yon and hydroxide anion. So, pwede magsama yon into ammonium hydroxide. Okay? So, that's basic kasi may hydroxide. The density of concentrated ammonium hydroxide, which contains 28% by weight ammonia, is 0.899 grams per ml. What volume of this reagent should be diluted to 500 ml to make 0.250 molar ammonia? Basahin uli natin yung last part ng question. Ang density, tinagalog na, ang density ng concentrated ammonium hydroxide, which is 28% by weight ammonia, is 0.899 grams per ml. Okay? Tapos ano yung sumunod na sinabi? Sumunod na sinabi ay, what volume of this reagent should be diluted to 500 ml to make 250 molar ammonia. Okay? So ano yung napapansin nyo dito? Given tayo ng percent by weight, then i-dilute mo siya. Balik tayo sa concept ng dilution. Okay? 'Di ba ang formula for dilution ay molarity initial volume initial equals molarity final volume final. So ano yung unit ng concentration na kailangan dito? Molarity. Okay? Ano yung meron tayo? Percent weight initially. Yung final kasi ito 0.25. So yun yung final molarity. Yun yung after dilution, 'di ba? Yun yung target. Pero, before the dilution, ano yung concentration unit natin? Percent weight. Hulaan nyo, ano gagawin natin? We are going to convert percent weight into molarity. Okay? So, ganun gagawin natin. Convert percent weight into molarity. So, ganun gagawin natin, ha? So, yun yung first step before we arrive with the final answer. So, katulad ng pinaggagawa natin kanina, let's assume 100 gram sample, solution, no? So, 100 gram solution, pangit ng bracket ko. Ito talaga hindi ko ma-perfect kahit anong mangyari. Ayan. Okay. So, let's have 100 gram solution. So, that is 28 grams ammonia. And the remaining will be water, no? So, ilan yung water dyan? 2. 72 grams H2O. Okay? Okay, so yan. So yan yung composition ng ating 100 grams solution. Tama ba? 100 yan. Okay. Then, what's next? Density. Kunin natin yung volume ng solution. So that will be 100 grams divided by the density, which is 0.899 grams per ml. So we solve for the volume of the solution equal to 3 decimal places lang, ha. 111,235. Okay, so yan. 111,235. So yan na yung volume ng solution. Then, we solve for the molarity. No? Molarity. So, molarity is mass ng ammonia. Molar mass ng ammonia. Tingin tayo sa periodic table. Hindi ko kabisado. 14,007, ammonia 1,008 times 3. So this is 17.031 gmol, grams per mole. Gmol basa ko dyan. And then yung volume, no? Which is 111,235 grams divided by, ml pala, sorry. ml divided by 1,000 ml per liter. So we solve for the molarity. Galit na galit tayo sa calcul natin. 28 divided by 17,235. Okay, so the molarity is 14.78. Okay? Kasi nakalagay sa calcul ko 14.7800. Okay, so okay na yan. So yan, 14.78 molar. Ito yung original concentration ng ammonia. So ngayon, punta na tayo sa mismong problem. Ano daw yung volume ng reagent na kailangan i-dilute to 50 ml to make 250 molar ammonia? Okay? So dito na papasok yung M1, B1, something, something. Okay? Maximize ko lang yung space. Okay? See? Lagyan ko na lang to ng border. Ang ingay na messenger ko. Okay. So yan. So let's answer the last part of the question. So anong equation gagamitin since that is dilution problem? M1 V1 equals M2. Final na lang. MF VF na. So since we are looking for the volume initial ng original solution natin, so the equation to be used will be ano? So since we are looking for V1, so anong equation gagamitin natin? O derive natin. That will be V1 equals MF VF divided by M1. Okay? So yan. So let's solve for V1. So okay, so molarity final, yun yung target natin. 0.25 molar times the volume, gawin na lang nating ml, divided by the molarity initial, 14.78 molar. So we solve for the final for the initial volume equal to okay, so that is 8.46. Okay, or 8.457. Although kapag volume na, yung 3 decimal places, medyo hindi na siya nagmamatter kasi ang vol flask natin, up to yung mga volumetric glasswares natin, up to 2 decimal place lang kaya nila. Okay, so pero okay na yan. So this is our answer, 8.46 ml of the initial volume, initial concentrate, reagent is needed, no? Ang kailangan ilagay sa 500 ml water to make the final concentration. Okay? So, ganun lang. Yan na yan. So, pwede kayo mag-screenshot. Wala nagbabawal mag-screenshot. No? Okay? So, yan. Okay, so let's proceed with the next one. Itong number 10, sasagutan natin ito. Dami, no? Okay. Siguro isa na lang muna dito. So ito, 8 sagutan natin. Ay, hindi. Sige, 8 na lang. Let's answer 8. Ito may stoichiometry dito. Si gravimetric analysis. Although yung approach dito would not be the same as the approach sa other questions. Case-to-case basis yan. Although yung equations na gagamitin, same lang. Okay? So, depende kasi sa hinahanap ng problem yung magiging approach mo. Okay? So, all you have to do is to read the problem very carefully. Okay? Pero yung equations na gagamitin, same pa rin. Okay, so let's have this one. In a gravimetric analysis, we need enough product to weigh accurately. Each tablet provides 15 milligrams of iron. How many tablets should be analyzed to provide 25 grams of iron 3 oxide product? Excuse me. Okay, so ang question sa atin is that how many tablets ang kailangan if each tablet will give us 15 milligrams iron to get 25 grams of the iron 3 oxide product. Okay, so anong gagawin natin dito? Okay, so we start with this one, yung given substance. Ito yung given Okay, bakit? Kasi given yung formula, given yung mass niya. So gagawin natin, first technique natin, gawa natin to ng flow chart, flow. So from mass ng iron 3 oxide, ko-convert natin siya into mole ng iron 3 oxide. Okay? So convert muna natin siya into moles of iron 3 oxide. Then ano susunod, Yung mole ng iron 3 oxide, we will convert that into moles of iron. And then, we will compare the moles, hindi pa pala. Yung mole ng iron, ko-convert natin into mass ng iron per, yung mass ng iron na kailangan for the reaction. That is equivalent to this mass, So again, anong ginawa natin? Baka nawala tayo. So ganito yung gagawin natin pala. So we start with this one. Ito kasi yung kailangan natin. 25 grams of iron 3 oxide. So, ang kailangan natin gawin ay ganito. So we start with the mass of iron 3 oxide. We convert that into moles of iron 3 oxide. And then from the moles of iron 3 oxide, we will convert that into moles of iron. Bakit pa kailangan, sir, ng iron? Kasi pag alam mo yung amount ng iron na kailangan mo sa experiment, you can solve for the number of tablets. Kasi sabi dito sa part ng question na to, each tablet will give us about 15 milligrams of iron. So, kailangan alam muna natin kung ano yung mass ng iron na kailangan mo overall. Okay? And then, we will compare that sa, mass ng iron per tablet, So, we can solve for the amount of, or the number of tablets necessary, to carry out this reaction. So, again, from mass ng iron 3 oxide, okay? Yun yung kailangan talaga natin, Okay, so from mass ng iron 3 oxide, that will be needed, to carry out the experiment, convert mo siya to moles ng iron 3 oxide. Then from moles of iron 3 oxide, we convert that to moles of iron. Bakit kailangan iron? Kasi each tablet, ang meron lang tayong info ay yung iron kada tablet, given by this part of the question. Okay. So yun, ka-convert natin siya to iron, to the mass of iron eventually. Then, aalamin natin kung ilang tableta ang equivalent sa ganung mass ng iron, given that each tablet will give us 15 milligrams of iron. Okay? So, let's do that. Medyo mahaba lang itong solving na to, pero kaya-kaya yan. Okay? So, let's start. So, mass ng iron 3 oxide to mole. Okay, so let's do that. So, mole Fe2O3. So, that is mass over molar mass. So, 0.25 grams daw ang kailangan. And the molar mass for iron 3 oxide ay Solve natin. 55,845 times 2, 15.999 times 3. So that's 159.687 Gmol. So, ano yung sagot natin dito? So, mass divided by the molar mass, that will give us 1.566 times 10 raised to negative 3 mole of iron 3 oxide na. So, yan, nandito na tayo sa part na to. Isang equation lang ginamit natin, andyan na tayo. Okay? So, what's next, no? What's next is that we convert the mole of iron 3 oxide to mole of iron. Okay? So, ito yung step 1. So, punta na tayo sa step 2. So, from mole of iron 3 oxide to mole iron. Paano yon? Dimension analysis. Conversion lang. Stoichiometry lang yan. Okay? So, paano po yung stoichiometry dyan, sir? Okay? So, sulat nyo, mole iron. Ito, isa-solve natin. So, ano yung given natin? Mole iron 3 oxide. Then, we have to convert this to mole ng iron. Paano? Using stoichiometry. Ibig sabihin nun, it will involve fraction. Okay? So, ano yung kailangan ma-cancel? Ito yung original substance mo. Okay? So, mole Fe2O3. So, yan yung ika-cancel mo, di ba? And then, ano yung nasa numerator dapat? Yung gusto mo ma-solve. Ano ba yung gusto natin ma-solve? Yung iron. Mole iron. So, hindi to complete, no? Kasi, alam natin kung sino nasa numerator, yun yung gusto natin makuha, which is yung iron. And alam natin yung nasa denominator, yun yung gusto natin ma-cancel out, which is the mole of iron 3 oxide, no? Pero ang question doon is, ano yung equivalence nila? Ano yung stoichiometric factors nila? Sir, paano namin malalaman yun? Just look at the formula, okay? So, kung titignan nyo yung Fe2O3, okay, if you have 1 mole of that substance, ilang iron yung katumbas ng Fe2O3? Tignan nyo yung formula. Ano yung subscript ng Fe? 2. So, ibig sabihin nun, 1 mole of Fe2O3, iron 3 oxide, will give you 2 moles of iron. Okay? So, ito na yung stoichiometry part, no? So, ang gagawin nyo lang, just look at the formula, Fe2O3. So, ibig sabihin, isa neto, dalawang iron makukuha mo. Sir, paano naging dalawa? Yung subscript, no? So, Fe2, ibig sabihin nun, dalawang iron meron sa molecule na to. Okay. So, that means, dalawang iron yung equivalent dito sa molecule na to. Okay? So, ganun lang. So, yan. So, yan yung conversion natin. So, basically, what we're going to do is to multiply this by 2. Ta-times 2 mo lang yan. Kasi, yun yung nakalagay dito sa equation eh. This times this, no? 2 divided by 1, edi 2. Okay? So, solve natin. Mole Fe. 1.566 times 10 raised to negative 3 times 2. So that will be 3.132 times 10 raised to negative 3 mole iron na tayo. Okay, so andito na tayo. Then ano pa yung gagawin natin? From mole iron, gagawin nating mass ng iron yan. Hindi pa tayo tapos. Daming steps, no? So kunin natin yung mass iron. Paano yun? Mole iron times the molar mass of iron. Okay? Okay, so that's 3.132 times the molar mass of iron, which is 55.845 grams per mole. So, ang mass ng iron na kailangan daw sa experiment ay 0.175 grams iron needed in the experiment. Hindi pa yan yung final answer. Ang ginawa lang natin from ang ginawa lang natin ay from mass ng iron 3 oxide, ginawa natin siyang mass ng iron. Okay. Bakit? Kasi kaya ang pinaka-question talaga sa problem is yung dami ng tablets na needed, no? Para may ganitong amount ka ng iron 3 oxide, okay? So, since alam natin na in order to carry out this experiment, this amount of iron is needed, no? And each tablet will give us 15 milligrams of iron. So we solve for the ano, we solve for the number of tablets needed, no? So paano natin isosolve yung number of tablets na kailangan? Okay, ano yung given sa atin? Ito. Ito yung 0.175 grams of iron needed, no? Okay? Tapos, each tablet gives us 15 milligrams of iron. Convert natin yan into grams. Okay? So, 15 divided by 1,000, 0.0015 milligram. Ay, ba't milligram? Sobra pala ako ng 0. FE per tablet. Okay? So, ito yung dalawang given na natin. So, kailangan natin ng 0.175 grams of iron and kada tableta, meron siyang 0.015 grams of iron. No? So, ano na lang kailangan natin gawin dito? Kunin natin yung ratio nila. Okay? So, to solve for the number of tablets, ano gagawin? So, kunin nyo lang yung ratio niyan. So, 175 grams iron ang kailangan. 0.015 grams iron per tablet. So, magka-cancel yung iron. You will be left with the tablet units, no? Okay. So, parang conversion lang talaga. Okay. So, yan. So, matitirang unit mo ay tablets, no? Na-cancel out na natin yung iron. Pati yung grams. So, bale, so ilang tablets kailangan? 11.66. 11.67 tablets ang kailangan, or we can round it up to 12 tablets. Wag mo na putulin yung tablet na isa, sayang eh. Okay. So ganun lang. So ganito yung itsura ng gravimetric analysis sa Anachem. Daming conversion na nangyayari. Okay. So again, paano yung nangyari sa ating calculations? Teka lang. Wait lang. Sir, saan po uli nanggaling yung 0175? Ito po, dito siya nanggaling. Di ba ang ginawa natin, from mass ng iron 3 oxide na kailangan sa experiment, kinonvert natin siya to mass ng iron. Okay? So, ginawa natin yon. So, ito yung solving na yon. Tatlong steps yon. Stoichiometry yon. No? Ayan. Then, once na makuha na natin yung mass ng iron, i-compare natin yon sa gaano karaming iron yung meron kada tableta. Ito yon. Okay. Yan. So, by comparing the amount of iron needed with the amount of iron per tablet, no, by just comparing the two, meaning ng comparing, i-divide mo sila. Okay. So, by dividing them, makukuha mo yung amount ng tablet na kailangan mo. Okay. So, yun yung ganap sa question na to. No? So, you start with iron 3 oxide. Ko-convert mo siya sa iron. Bakit kailangan i-convert sa iron? Kasi kailangan natin yung dami ng tablets, no? That will give us this amount of iron. Okay. So, ganito yung gravimetric analysis. Okay. Highlight ko na lang yung mga items. May ganito ba sa quiz, sir? Wala naman. Sa gravimetric analysis pa to eh. Sinama ko lang talaga para may idea na kayo. Ayan. So, hinighlight ko saan nanggaling yung info na. Okay. So, ayan. Screenshot nyo na lang. Medyo mahaba, no? Kaya, yung quiz ninyo, 20 items yun. Use your time wisely na lang. Okay. So, ganun. Ayan. Kaya nga, may pagpa-practicean na kayo, no? So, ayan. Sir, lahat po ba solving sa quiz? Meron ding concept, no? For example, yung solutions. Sino dito yung electrolyte solution? Sino dito yung non-electrolyte solution? Okay. So, may ganun sa quiz, no? So, mayroong easy, yung mga kaya sagutan in 1 second, no? Isang tingin mo lang, ito, electrolyte solution to. Ito, non-electrolyte to. Then, yung ibang part, yun na yung average and difficult, yun yung solving na. So, yung solving natin, pwedeng mas madali siya as solving for the molarity lang. Then, yung mga difficult type questions, medyo ganito yung style. For example, ito, ang daming conversion para makuha mo yung final answer. Yung ganito, sa gravimetric analysis na yan na madidiscuss. Although, pwede rin naman gamitin yan sa topic natin ngayon. Okay? So, ayan. Use your time wisely. Although, tignan ko kapag, tignan ko kung ano yung magiging outcome. Kasi pwede ko naman extend yung quiz time nyo, no? From 1 hour, pwede ko siya gawing 1.5 hour, no? So, ganun. So, yun, that will give you plenty of time, no? Tignan ko kung kaya ko pa mabawasan yung, questions and yung problem solving. Pero kapag di ko na kaya mabawasan, edi marami talagang problem solving. Pero as ako, naman, as pampalubag loob, bibigyan ko kayo ng more time to accomplish the quiz. Okay. Siguro okay na yung 1.5 hour. Kasi itong problem na to, kapag sinolve mo yan ng dire-diretso, lang yan 5 minutes, 6 minutes na. Pero syempre, kapag students, mga 10 minutes yan or 11 minutes. Kaya minsan di mo na siya sasagutan, no? Hula ka na lang ng item. Okay. So, ayan. Basta masasanay din kayo sa solving. Okay. So, let's proceed with the last one. Okay. Para makapag-lunch na rin tayo dahil ako ay nagugutom na rin. So, ito yung nasa PowerPoint. A solution was prepared by dissolving 1210 milligrams of potassium. Paano ko babasahin to? Complex kasi to eh. So, potassium, ferric, hexacyanide, basta mga ganun. So, K3FeCN6, no? Meron kasing topic sa Anachem na babasahin natin to. Although hindi na natin i-cover kasi pang BS Chem na yan. Okay. So, bale, ito yung ganap na. So, ito yung, we have 1210 milligrams of this substance. Ito yung molar mass. Okay, so thank you sa molar mass. Insufficient water to give 775 ml. We calculate for all the following information. Okay? So, ganito. Bibigyan ko na kayo ng tip, no? When you dissolve this substance, itong K3FeCN6, no? Kapag dinissolve mo yun sa iyong water, ano mangyayari? So, when you dissolve that in water, it ionizes into ganito. Sulat ko yung ionization reaction. K3FeCN6. Kapag yan nilagay mo sa water, that ionizes into K+, and the anion is FeCN6 minus 3. Okay, so ito yung kanyang stoichiometry. No? So 1 mole of this substance, KeFeCN6, no, it will dissociate into 3 moles of potassium ion. Galaw ng galaw yung screen. So this will dissociate into 3 moles of potassium ion and 1 mole of this anion. Okay? So yan. Usually ibibigay ko naman yung reaction kapag sa quiz, no. Tapos kayo na bahala gumamit ng stoichiometric factors, no. So basta yan. So ito yung cation, ito yung entire anion. So let's calculate for A to H. Okay. Sige. So letter A, the molarity, the molar analytical concentration of the substance. Kapag sinabing ganyan, molarity lang yan. Okay? Sa molarity lang yan. So A, let's calculate for the molarity of K3 something something. Okay, so molarity in square bracket ko na lang. Okay, para ma-identify natin kung anong substance yon. Okay? So what is molarity? Mole per volume of liter, volume of solution in liter. So that's mass of your solute. Ito yon. However, naka-milligram to. Gagawin natin tong grams. So gawin natin yung grams. 1210 divided by 1,000, 1.210 grams. Ano yung molar mass niya? Given naman. So, kopyahin na lang natin yun. 329.2 Gmol. By the way, kapag given yung molar mass, yun na lang gamitin nyo. Pero kapag hindi, susolve nyo yun. Volume of the solution in liters. So, we have 775 ml. In liters, that will be 0.775 liters. So, ang sagot sa AI, madali lang, no? So, that will be 4.74 times 10 raised to negative 3 molar. Okay? So, yan yung concentration ng K3FeCN6, no? Letter B. The molar concentration of K+. Paano yan, sir? Ganito na lang. Since nakuha na natin yung concentration nito, di ba, nakuha na natin concentration yan, which is this one, okay? So since we are able to solve for the concentration of that substance, we can use stoichiometry. Pwede na tayo gumamit ng stoichiometry para makuha yung concentration ng other substances, no? Okay? So, sulat ko lang yung dissociation reaction. Okay. So, since this substance, ito, ayan. So, since this is 4.74 times 10 raised to negative 3 molar, by the way, dalawa yung masasagot natin dito. Ang masasagot natin ay yung B pati yung C. Okay? So, since ayan yung concentration niya, ang question is, ano yung concentration ng potassium and ano yung concentration ng FeCN6 negative 3. Okay? So, ang sagot ko doon ay stoichiometry. Okay? So, ganito. Kapag may kapag may coefficient na 3 doon, ibig sabihin nun, times 3 na to yung concentration. Okay? As long as 1 yung coefficient niya. Okay? So, parang ganito lang yan eh. Pakita ko kung paano yung solving yan. Although, pwede naman gawin yung mental na lang. So, ganito lang yan. Molarity of K3FeCN6, no? Ang conversion dyan is yung coefficients, no? So, 1 mole of K3FeCN6. Then, yung equivalence niya to K+, no? So, 3 moles K+. Okay. So, basically, to convert the molarity of this substance to that substance, Parang nag-i-stoic ka lang. So, ika-cancel mo yung K3, FEC, and 6. Ang matitira ay K plus. Okay. So, ibig sabihin yung multiplied the molarity by 3/1 or basically 3. No? So, gagawin mo na lang dito, ito times 3 mo na lang yung concentration niya. So, ganun lang. Ganyan yung mga shortcut dito. Provided, ito, may ano na naman ako. Provided that yung coefficient nito ay 1. No? So, kung 1 yung coefficient niyan, kung ano yung coefficient nun, yun yung i-multiply mo doon. Paano kunwari, 2 ito? Kunwari lang ha. Sir, paano kunwari 2 yan? Ano mangyayari dito sa fraction na to? Magiging 3/2 yan. Okay. So, pag 3/2 yan, hindi siya times 3. No? Times 3/2 yung gagawin mo. Okay. So, ganun yung mga mental maths dito. No? So, kapag 1 yung coefficient niyan, that means ito, kung 3 yan, edi times 3 mo lang yan. Ito, kunwari 2 to, edi times 2 mo lang. Pero kapag hindi 1 yung coefficient niyan, magfa-fraction ka pa. Okay? So, yun yung mga techniques na ginagawa dito. So, titignan mo lang yung formula. Again, kapag 1 yung coefficient niyan, i-multiply mo yung concentration by the coefficients. No? Pero kapag hindi yan 1, kunwari 2, 3, so on, magfa-fraction ka pa. Okay? So, paano ko po malalaman yung fraction? Ganito lang. In stoichiometry lang. Usual stoic conversion. Okay? So, yun lang yung tip na masishare ko sa inyo. Ay, gamit nyo yan pagdating ng equilibrium. No? As in, super gamit na gamit yan. So, ngayon pa lang, i-note nyo na. Okay? Kapag 1 yung, kapag 1 yung tawag dito. Pag 1 yung coefficient yan, kung ano yung coefficient ng iba, dun mo i-multiply yung concentration. Pero kapag hindi yan 1, kunwari 2 yan, 3 yan, 4 yan, magfa-fraction ka pa. Sir, paano ko malalaman yung fraction? Stoic lang. Stoic. Okay? Anyway, paulit-ulit na ako. So, ito. To get the molar concentration of K+, sabi dun sa letter B, times 3 ko lang yan. So, that will be teka lang. 4.74 times 10 times 3. So that is, kung ano na lang nakasulat dito sa calcu ko, yun na yung susulat ko dito. So that will be 0.01422 molar. And for letter C, the concentration of FEC and 6 minus 3. So times 1 lang yan kasi kung ano yung coefficient neto, parehas yun doon. So that means times 1 lang ito. Okay. Okay, so yan. So ito yung sagot sa letter B. Ito yung sagot sa letter C. Letter D. Weight per volume percentage of K3FeCN6. So yung weight per volume, edi weight per volume lang yun. Okay, so para siyang density lang. So pag sinabing weight per volume, parang density lang yan. Parang density lang yan. So yung weight nyo naka-grams, ang volume nyo naka-ml. No? Parang density lang. So let's solve for that. Weight, volume, percent weight per volume. So ano yung mass ng K plus? Ay K something something natin. 1210 milligram or 1.210 gram. Okay. K3 something something. Okay. So yan. So yan yung mass ng ating substance. Teka lang, sulat ko ulit na maayos. And yan. Divided by the volume of the solution in ml, 775. So parang density lang talaga, no? Kaso, since percent to, times 100 yon. So our answer here our answer here will be 0.16 na lang. 156 0.156% weight per volume. Okay. So, ganun. Again, kapag weight per volume, usually that's grams per ml. Parang density lang. However, since may percent, the times 100% yan. Okay? So, yan yung sagot sa D. Letter E. Letter E tayo. Naubusan ako ng space. Sabi sa letter E, calculate the number of millimoles of K plus in 50 ml of the solution. So, hinahanap ang millimoles. M-mole yan. Okay, so pag millimoles, yan yung symbol niya, M-mole. Okay, so yan yung millimoles of K plus in 50 ml solution. Okay, so to answer this, ang question dyan is, alam mo na ba yung concentration ng K plus mo? Alam na natin. Ano yung concentration ng K plus? Yun nasa letter B. Okay, so to solve for the millimole, okay, so we need to use the the molarity, no, and the volume given by this problem or by this question, no. Okay, so bale, to solve for the millimoles, solve mo muna yung mole. Yan, molarity times volume, di ba? So pinagsasama-sama na natin lahat ng info, ha. So molarity ng K plus nyo, K plus, ang molarity ng K plus ay 0.01422 mole per liter K plus times the volume na sabi sa problem, which is 50 ml. Yung 50 ml gawin nating liters. So that will be 0.05 liters. So that will be equal to 0.01422 times 0.05. 7.11 times 10 raised to negative 4 mole. Okay, so ganun lang. So again, paano kinukuha yung millimoles? Molarity lang times the volume in liters. However, since sabi sa problem, millimoles, ang meron lang tayo ay mole, we have to convert this. Ano yung conversion ng millimole sa mole? Hulaan nyo, 1,000. Okay. So, 1 mole is equivalent to 1,000 millimole. Okay? So, cancel mo yung mole, matitira ay millimole. No? So, times 1,000 mo lang yan. So, you will get the final answer, 0.711 millimole. No? So, yan. So, yan. May shortcut dito. Pakita ko sa inyo yung shortcut. Okay. Para makuha nyo yung millimole agad-agad na hindi na kung ano-ano yung pinaggagawa natin, ay ganito gagawin nyo. Kunin nyo yung molarity ng K plus and i-multiply nyo yun. Teka lang. Dot na lang para hindi confusing. Kunin nyo yung molarity ng K plus and i-multiply nyo sa volume in ml. Kapag molarity times ml, ang sagot doon ay millimoles agad. Okay? So, pakita natin. Yung mga shortcut na yan, magagamit nyo yan sa titration. So, paki-note na agad, no? Okay. So, yan. So, molarity, pag minultiply mo yan sa volume in ml, millimole ang sagot, na. Okay. So, C. 711 millimole ang sagot. So, yun yung direct na. Yun yung shortcut. Okay. So, as you can see, we still ended up with the same answer. No? Ayun. So, ito yung common technique talaga, no? You convert molarity, you convert the volume to liters para mag-cancel yung liters, then i-multiply mo siya by 1,000 to get millimoles, no? However, ito yung shortcut, no? Kasi tignan mo, yung volume, dinivide mo sa 1,000, then eventually, i-multiply mo uli sa 1,000. Okay, so basically, kapag minultiply nyo yung molarity by the volume in ml, millimole talaga yung sagot doon. Okay, mathematically speaking. Okay, kasi dinivide mo by 1,000, i-multiply mo rin later on by 1,000, di ganun din, di ba? So, yan. Yan yung shortcut, no? And, paki-note na lang kasi magagamit nyo yan sa titration. Okay, so yan, nasa letter E na tayo. Okay, so ngayon punta tayo sa F. F, ay, daming sinusolve dito. Kakapagod pala tong item na to. ppm, ayun, ppm, ano yun, fe, cn6. Kunwari ito, ppm naman ng solution. In solution. Ano formula ng ano? Ano formula ng ppm? Milligrams of the solute per liter of solution. May milligram tayo sa problem. Kaso ano problema? Kay Fe, kay ano yon, kay K3FeCN6 eh. Hindi siya kay FeCN6 -3. Okay, so salt yon, hindi siya sa ion. So ano pwede natin gawin dito? Hulaan nyo. Alam na natin yung molarity ng FeCN6, di ba? Ito na yun eh. So pwede gawin natin from the molarity, kunin natin yung moles niya. Okay, then from moles, kukunin natin yung mass, no? And then we convert that to milligram. Then pag nakuha na natin yung milligram ng FeCN6, di-divide na lang natin yung by the volume of the solution in liters, and that will give us the ppm. Ang daming steps na. So ganun talaga. Welcome to Anachem. Okay? So ganun yung gagawin natin. Pakita ko sa inyo yung flowchart. Okay? So from the molarity of FeCN6, pag square bracket, again, molarity yan. Ko-convert mo yan into mole ng FeCN6, no? Then yung mole ng FeCN6, no? Ko-convert mo yan to mass ng FeCN6. Ang daming sinosolve, sir. Yes. Maski ako napapagod din. So from, ko-convert mo siya to mass ng FeCN6, no? Then gagawin mo yan in milligrams. Okay? Then, after nyan, gawin mo na siyang ppm or milligram per liter ng solution. Okay? Ang daming steps. Kaya yan. Okay. So, meron na tayo na ito, concentration. So, ano yung step na gagawin natin? Gawin natin siyang mole ng FeCN6 na. Step 1. Step 1. Kunin natin yung mole ng FeCN6 -3. So that will be molarity times the volume of the solution in liters, no? Liters kasi molarity eh. Ay, mole yung gusto natin, hindi millimole. Okay? So, ano yung molarity niya? 474 times 10 raised to -4, -3. Okay, so that's the molarity times the volume of the solution in liters, 775 ml. So that is 0.775 liters. Okay, so magka-cancel yan dalawa. Makukuha natin yung mole ng FeCN6 na 4.74. So that will be 3. Kopyahin na natin lahat ng digits. 6735 times 10 raised to -3 mole ng Fe something, no? So, yan. So, nakuha na natin yung mole ng FeCN6, no? Next one, kukunin mo na yung mass niya. So, paano yon? Mole times the molar mass lang. So, hindi ako nag-round off kasi tuloy-tuloy yung conversion ko. Times 10, negative 3. Tapos, i-multiply mo siya sa molar mass ng FeCN6, no? So, kunin natin yung molar mass nun. Iron, ano yung molar mass na ito? So, iron is 55.845 times 1. Carbon, 12.011 times 6. Nitrogen, 14.007 times 6. No? Okay. So, again, last sem to, i-distribute mo yung subscript kapag magkukuha ka ng molar mass, di ba? So, kunin natin yung sum niyan. 845 plus 12,011 times 6 plus 14,007 times 6. So, the molar mass of this ion is 211,953 grams per mole. Okay, so ganun na. Kunin nyo yung molar mass niyan. Times 3.6735 times 10 raised to negative 3. So, ito na yung grams ng solute na yan sa ating solution. So, that's 0.779 na. Round off na natin. 0.779 grams of FeCN6. Kaso, gagawin ko, convert ko yan to milligram, gaya ng sinabi ko. So, 1 gram, 1,000 milligram. So, ano yung milligram ng FeCN6? So, times 1,000 mo lang, 779 milligrams lang yan. Okay, so now, since meron na tayong milligrams of FeCN6, last step, finally, last step na. Kakapagod na. So, ppm na lang. Okay, so, ppm of FeCN6. So, paano yung ppm ng FeCN6? So, that's mass of FeCN6 divided by the volume of the solution. Sulat ko dito para maalala nyo. Mass of FeCN6 in milligrams divided by the volume of the solution in liters. Okay? So, that's 779 mg divided by ano yung volume ng solution in liters? 0.775 liters. No? So, to solve for the ppm FeCN6 negative 3, medyo malaki yung number na yan. So, that is 1,005.16 ppm. Okay. Ang daming sinasolve, no? So, yan. Letter F pa lang yun. Okay. Ang daming nangyayari. Okay, so yan. So, tapos na tayo sa F na. So, basically, to convert your concentration to ppm, ang gagawin nyo ay kunin nyo muna yung moles ng concentration na yon, given yung volume. Then, yung mole na yon, i-convert nyo to mass, then to milligrams. No? Then, finally, yung milligram ng solute nyo, i-divide nyo sa volume ng solution in liters, you will get the ppm. So, ito yon. Ito yung steps na yon. Okay? So, yan yung lahat. No? Okay, so let's proceed. Letter G and H, malapit na tayo. So, for letter G, that's PK plus. Ay, ito madali lang. PK plus. So, ano yung P? That's negative log of the concentration of K plus. So, ano ba yung negative log? Ano ba yung concentration ng K plus? Sabi sa problem, yun ay 0.01422. Okay? Pindutin nyo na lang sa calcu, negative log 0.01422. So, PK plus is 1.85. Okay na yan. 1.85. Lastly, thank you Lord, FeCN6. So, that's negative log of the concentration of Fe something something. So, that's negative log. Ano yung concentration niya? Sabi sa problem, 474 times 10 raised to negative 3. So, plug in sa calcu. So, that will be 2.32. Okay? So, yan, we're done. Tapos na. Nice, thank you, Lord. So, we're done with our worksheet na. So, ganun lang. Ano yung mga technique na shinare ko sa inyo today? By the way, pag nabilisan kayo masyado, panoorin nyo na lang yung recording na to ulit, no? Tapos pwede nyo i-post screenshot, no? So, ganun. By the way, itong solution natin, aayusin ko pa to, ha? I-type ko to sa Word, no? Para maayos naman tignan, no? Upload ko siya by the weekend. Siyempre, matagal din mag-type ng solution sa Word, eh. So, give me time para ma-type ko yan ng maayos. Then, I will upload it sa Canvas, no? Okay. Then, maggamitin nyo yung reviewer, ha? Gamitin yung reviewer, ha? Huwag nyo lang titignan. Okay. Kasi kung napapansin nyo ngayon pa lang, ang dami nang nangyayari. Ganyan din sa quiz, no? So, good luck, no? So, alam ko sanay na yung mga former students ko dati. No? Parang, hindi na sila bago sa ganyang kahabang steps. No? So, kayo rin naman, syempre. Okay? So, yun. So, ano lang yung mga technique na gusto ko i-share sa inyo? Yung mga shinare ko sa inyo. Again, number 1, kapag given yung percent weight, no? Gagawin mo siyang, molarity. Yung, mag-assume kayo ng 100 grams ng solution. Then, kung ano yung percent ng solute, yun yung kanyang mass. To get the volume of solution, use the density naman. Sir, paano po, kunwari, percent volume, kukunin ko yung molarity. Pag percent volume naman, pwede mo gawin di 100 ml solution. Kaya pwede ring 1 liter solution. Okay? So, yan. So, 100 ml solution, 1 liter solution. Sir, paano ko po makukuha yung mass ng yung mass ng solute? Yung volume ng solution mo, convert mo into mass, no? Using density pa rin, no? So, dun lang umiikot yung formula, yung conversion sa density formula. Ano pa yung sumunod na additional natin ngayon? Molality. So, mole per kilograms of solvent yan. Kapag hindi concentrated ang inyong substance, molarity and molality are similar. However, if masyado siyang concentrated, ibig sabihin mataas yung percent by weight, nagkakahiwalay na yung values nila. Okay? Ano pa? So, yan, kunwari, dilution, given ang percent weight, ang gagawin nyo, convert nyo yung percent weight to molarity, then saka kayo mag-dilution. Okay? Then, another one is kapag may stoichiometric conversions na. Okay, so ano yung kailangan nyo lang i-take note dito? Okay? So, para malaman yung equivalence ng element sa compound or ng ion sa compound, you can do stoichiometry. So, ito yung part na yun. Hinahanap natin iron from iron 3 oxide. Just look at the subscript, no? Kapag nakita nyo Fe2O3, that means 1 mole of Fe2O3 is equivalent to 2 moles of Fe. Okay? Kasi sa formula na to, may dalawang Fe. So, ganun. Basic stoic lang yan. Okay? Ano pa yung mga additional info na pwede ko sabihin? Ito, mga dissociation reaction. Okay? So, ibibigay ko naman yan no, most of the time. Okay? So, ganun. Ano pa? Ano yung important doon? Kung ano yung concentration nito, as long as yung coefficient niya ay 1, para malaman mo yung concentration ng ibang substances, i-multiply mo lang ito sa coefficient nila. Okay? So, ganun lang. Kunwari ito, times 3. Ayun yung concentration ng K+. Kunwari ito, 1 din yung coefficient niya. So, kung ano yung concentration nito, yun din yung concentration nun. What else? Ang additional info natin, percent weight per volume. So basically, that is grams of your solute divided by the volume of solution in ml times 100%. Para siyang density. Naka-percent nga lang. Okay? Ay. Next one, yung millimole, no? So kunwari gusto mo millimole agad yung lumabas, so that is just molarity times the volume in ml. Okay? Volume in ml. That will give you millimole. Okay? If you divide millimole by milliliters, that will give you molarity naman. Okay? So, ganun lang. Magagamit nyo yan pag nag-titration tayo. Then, next one, from concentration, gagawin mo siyang ppm. So, paano yung steps doon? Yung concentration, yung molarity, gagawin mong moles. Then, yung moles, i-convert mo to milligrams, no? of the solute, no? Then once you have the milligrams, you divide it by the volume of the solution in liters. That will give you ppm values. Then lastly, yung p values, don't forget, that's negative log of the molar concentration of your substances. Okay? So with that, tapos na ang ating class, no? So medyo ang daming stuff na nangyari today, no? Yes, and that's why you really have to review for quiz 1. Okay? So yun. Ay, by the way, ito, side kwento ko lang. Nasa quiz nyo to eh. Always check for the volume changes. Okay? So yun lang. Kunwari, nagdagdag ako ng acid. Ito ha, kunwari lang. Kunwari, 5 ml of 0.3 molar HCl. Tapos dinagdagan ko yan ng 10 ml of 0.5 molar HNO3. Kailan i-open yung quiz, sir? Next week pa naman. Most likely, Monday, mga ganun. Yung Sunday kasi, doon ko palang ma-upload yung yung written answers na. No? Pero it doesn't mean na sa Sunday pa lang kayo magsasagot or magre-review, ha? 2 tries, sir. Usually, 1 try. No? Pero kapag nakita ko yung curve, hindi siya good curve, pwede ko gawing 2 tries. Nagkaganon ako minsan. Although very rare. No? Kunwari, nakita ko scores nyo kapag ganun. 2 tries yan. Pero kapag yung score nyo ay ganito, okay na yan. No? Pag yung score nyo ganito, okay na yan. Gets nyo talaga. No? Okay. So, hopefully, ganito yung curve natin. Pero kapag nakita ko nakaganon, edi pwedeng meron tayong remedial quiz, no? Although, tignan natin kung ano mangyayari. Hopefully, normal curve tayo. Okay? So, nasa curve ang sagot, no? Pag board exam, ganun din naman eh. Nagko-curve-curve, no? Okay, so kunwari, ito, magmi-mix ka ng dalawang acid, then ang question is, what is the concentration of H+? Teka lang ha. Wait lang, may call. Hey, ma, ako ta. Okay. So, ayan. Kunwari, ganito yung question. Pinaghalo mo yung dalawang solution. Tapos tinanong, what is the final concentration of this ion? Okay, so kunwari lang. Wag na lang HCl. Although, ganun din yung concept. Kunwari K+. KNO3. Tapos ito KCl. Sige. What is the final concentration of K+ in the solution? Yun yung question. Ganito. Alam nyo na kukunin nyo yung moles dito kasi given yung volume, given yung molarity. Okay? So, kunin nyo yung moles of K+ in KNO3. So, paano yon? Millimole na lang. Okay? So, that's 5 ml times 0.3 molar. Ano siya got? 1.5, no? So, 1.5 millimoles K+ yan. Okay? So, K+, 1:1 lang naman yung ratio ng KNO3 sa K+. Ito, binibigay ko na yung tips, ha? So, next one. Find the millimoles sa KCl. So, the same pa rin, 1:1 yung ratio. Kasi isa lang yung K dito. Oh. Isa lang naman yan, di ba? Okay. So, dun mo malalaman kung 1:1 ang ratio. Just look at the formula. Kung yan ay K2, edi times 2 mo yan. Times 2 mo to. Okay. Ito times 2 mo yan. Pero since 1 lang yung subscript, edi 1 lang yung equivalence niya. So, pakinote yung mga ganong info. Kunwari ito naman, millimole of K+ dito sa KCl. So, that's 10 ml times 0.5 molar. So, that's 5 millimole K+. To find the final concentration, okay, so final concentration of K+, that is the moles total divided by the volume total. Important to sa titration. Kaya ngayon pa lang gusto ko na i-share. Kasi nasa quiz din to eh. So, ipag-add nyo lahat ng millimoles. No? So that's 1.5 plus 5 millimole. Okay? Then, yung volume total. Kasi naghalo ka ng dalawang solution, di ba? So, ano yung volume total? 5 plus 10 ml. Again, millimole divided by ml is molarity. Okay, so molarity yan. So, ganun yung kapag magmi-mix ka ng substances. So, 1.5 plus 5, 5 plus 10. So, ang final molarity ng K+ ay 0.43 molar. So, ganun ha. So, that's how you do calculations na involving yung paghahaluin nyo yung dalawang substance. Okay? So, yan. So, good luck na. So, nasabi ko na naman lahat ng mga tips na magagamit nyo sa quiz, no? I just want you to practice lang. Okay? So, again, the solutions will be uploaded by Sunday, no? Kasi Saturday may gagawin ako. So, Sunday, doon ko siya ma-upload. Then, starting Monday, doon ko ma-open yung quiz, no? So, good luck po. So, yun lang. And that's all for today. Do you have any questions or gutom na rin kayo? Or okay na tayo? Etong video na to, upload ko siya later this night, no? Di ko agad siya na-upload last time. No? Wednesday ko siya na-upload yung class natin last time. Kaso, ang problema, hindi ko pala na-publish. Yung nagtanong eh. Okay, si Lyle. So, sorry, ngayon ko lang nakita yan eh. So, hindi ko pala na-publish yung video. Na-upload ko siya pero hindi published kaya hindi lumabas sa playlist. No? So, ngayon, available na yon. Itong class naman natin, mamayang gabi ko siya i-upload sa YouTube. No? Para makapag-review na kayo. Then, Sunday, upload ko yung answers. Then, Monday, quiz na. Okay? So, yun lang. If you have no any other questions, then we're good to go na. Okay? So, I'll see you again sa next week, no? Ingat kayo always and galingan nyo po sa first quiz. Good luck and all the best. Okay, bye-bye. Thank you.